Hello everyone. So in this video we will cover the following learning objectives. These are approaches to creating advanced assemblies, standard mates, concentric, coincident, and at an angle, mate alignment, assembly origins and selecting views, and lastly center of mass. So we have been provided with a PDF that contains this assembly model. It contains all the information you need in text. So this would also be how much of each part you need, what unit you're supposed to use, the placement of origin. After you open your files, it might ask you for feature recognition. If so, please click no. It will also tell you that your assembly is with respect of the origin as shown in the isometric view. Why this is very important is because if this is not paid attention to, or your origin is not exactly the same, or if you move your assembly around and create it in a different view, it would affect your center of mass, because in this question we will compare the center of mass of our assembly with the final answers that are provided. So one of them is correct, so if it's within 1%, that would do. You're also given information on what sort of mates you're supposed to use. Pins are mated concentric to chain link holes. Pins and end faces are coincident to chain link side faces. Also, you're provided with various angles A, B, C, and D, which are applicable to your main model. So we will use this side by side as we create our own assembly. We will begin with a numeric assembly because the unit noted down in the PDF is mmgs. Now we will pin that down before we begin. Now you would notice that the first long pin is mated at the origin, so we will drop that down there and place our second long pin anywhere. We need 3 short pins. Again, this information is within the PDF, and 4 chain links. We'll accept that. After we've placed everything we need, we'll begin by creating mates. Now, I would encourage you as you go through your own assembly, as you create a mate, and once you start creating mates, do not move the 2 parts around at all, as it might influence your final center of mass. So we will go for an isometric view and begin mating. Select this and this, accept that. Select this face here and this face there. Go for a coincident relationship, accept that. Next you will create a chain link here and over here, accept that. This face and this face, that should give you coincident, and we will accept that. Next we need is one of our short pins. Click this surface, this face here, accept that. Select this face and go for a coincident relationship, and we will accept that. So now we have moved on to creating our first angle, so that will be between this surface here and this surface there. Select the angle option, make sure it's 25 degrees, and also make sure it is pointing in the right direction. So this is supposed to be pointing downward, so we will just use flip dimension and correct that, and then you can accept it. Next we will create our second relationship between our chain links. Now once that is created, you would notice that this is placed on the other side. We could always use flip mate alignment to correct that. So we will accept it. Select this surface here, and well, you can't really click that surface, so you'll have to zoom in a bit. Select the surface there. Or you could have selected the other surface, that's okay too. And now we will create a relationship between the small pins and the chain link. So it's a very straightforward assembly. Next we will create an angle between this edge here and this edge there. Make sure your angle is 125. Now so you see snap back into it. So if it was created like that, moving it around might move your entire assembly, and that is discouraged because it affects your final value. So once you enter 125, it will rearrange it, so you don't really have to move it around yourself. Now the alignment is off, so we will play around with it a bit. Nope. Okay, so it's supposed to be pointing there, and we will accept that. Select this here and this here, accept that relation. Select this surface here and this surface there, we will accept that coincident relation. So we are making sure our relationships are coincident and concentric throughout our assembly. and we will accept that. This surface and this surface. Now all we have left is mating this long pin and this chain link and one last angle. So it's between this surface and this surface. Again, you can select edges as well. It's whatever you're comfortable with. This is supposed to be 130 degrees. Again, we will use flip dimension. That's not working out, so we will use mate alignment and make sure that this is pointing upwards, and we will accept that. We will create our last mate, and we'll select this surface and this surface. Accept that. Again, go for an isometric view and you will accept it. Now we will go under evaluate, check for mass properties, and compare them to the mass properties in one of our 4 options. So we can use these side by side. But the center of mass that we have been provided there is 384.66. That's 384.66. Negative 88.48. So the negative and positive are also important, so make sure those are correct. And negative 91.40. According to this, A should be your correct answer. Now, since we are done with that, I will show you why moving your parts around after you create mates will not be such a good idea. So if I use this edge, well, that won't move. If I use this and I will move it around, you could see your whole assembly is moving. So since we are in the isometric view, that would impact on what your final thing should look like. Now if you go under mass properties after we rebuild this, you would notice there's a significant change in the center of mass. The 348 is now a 193, and instead the last value, which was negative 91, has become 304. So when you're creating advanced assemblies, make sure you do not rotate your assembly because it could alter your center of mass. Make sure your view is correct. The first part that you made is mated correctly with the origin, your main assembly's origin. And also keep tallying A, B, C, and whatever values you're supposed to use. I hope you guys enjoyed the video. Thank you very much for watching.